Yes.
બધું બરાબર છે? Health, studies,
Yes,
right?
ma'am.
Say yes if it is. Okay, so you can see the screen. And we'll start, right? So everybody can see the screen.
Yes, ma'am.
Okay. So anybody, any queries up to last time? Up to last lecture? Okay. Anyway, so see, what did we see last time? We saw the models. They were not 100% correct, right? Model in the sense that something equation that can predict, okay, some way you can predict the I and V. Kitna voltage will appear across the diode or across the output, and how much current will be flowing, and so on. So when voltage is the concern, and we are working at high voltages, and to get crude kind of analysis, we do use this ideal diode model, right? Then linear, we saw all this, right? So this was ideal diode model we first used. Then this is constant voltage drop model, where you will see a constant drop of 0.7, and we approximate that then after 0.7 unlimited current will start flowing and the drop will remain 0.7. We can show this by this equivalent model here, where this symbol is a representation of the direction of the current and nothing more. And since it is a diode, we will use the symbol. And this is 0.7 volt here, so which is a drop. Okay, so that's what we did in the next step. And then we used piecewise linear model, in the sense that this is not a straight vertical line. We will approximate still, nearer to the real curve of the diode. And this is piecewise linear model, we say, where you can see that there is a slope. The line has a slope, right? And that is given by change. If you take a little area, right, a little piece here, then it is a change in ID, delta ID upon delta VD. So for that is the slope, okay, and that is 1 upon RD, and it is dynamic. So whatever, this is a straight line, okay, so it will remain constant. But here, when it is an exponential like this way curve, then RD will change. Okay, this is a straight line, so the slope is same. This slope, this slope, this slope, everything is same. And that's why it is 1 upon RD. But here, it's going to change, and hence we say it is a dynamic resistance. It is changing, although the change is little, but it will change, right? And here you will have at this point, then let's say 0.7, it is conducting, then 0.71, 0.72, 0.73. So the voltage difference is very less, but you will see a huge rise in the current, okay? And that's what we saw here also in the equation form, that if you take the ratio of the current, right, as 10 times change, okay, then the change in the voltage for 10 times change in the current is 60 millivolt for n is equal to 1, and 120 millivolt for n is equal to 2. So this is one equation that you will use in problem solving, and this graph shows the I and V with respect to temperature. So with rising temperature, let's say T2 is greater than T1, then more current will flow or less? Who will tell me? If T2 is higher, let's say T2 is 45 degrees centigrade and T1 is 25. Okay, 25, 45. T2 is 45.
Higher.
Then at 40, higher current ratio, because these bonds will break, which will result in more carriers and hence more current. It is that simple only. So the thing is that at a higher temperature, so for a same current, let's say this is same current, right? At higher temperature, you will need less voltage, right? So for at higher, so same current, okay, that is I only. Then here, this is the voltage. You will need this much voltage, and at this is lower. This is let's say 25 degree. This is 45 degree, right? For example, here the change is how much, that I will just tell you. Wait, wait, wait. Yeah. So here, so this voltage is higher than this voltage, right? So for the same current at higher temperature, you will need lower voltage to get the same current compared to the one that you get at a lower temperature. So that is that one. And what is for the diode? It is 2 millivolt per degree centigrade. So here, for the same current, the difference is for 1 degree centigrade. So if this is 26 and this is 25, then this difference is 2 millivolt. Okay, that's what it means. Okay, so for 10 degree change, you will get 20 millivolt change. This change in the current for getting the same I. Okay, and so that's all we had seen. And reverse bias, when the diode is reverse biased, you know that anode voltage is less than anode is what? Positive. Right? So positive is reverse, is less than the cathode voltage. So if V is negative and larger than VT, so VT is what? What is VT here? We had seen. Anybody remembers what is VT?
Thermal voltage.
Thermal voltage, and it is given by Kt upon Q. And for room at 25 degrees centigrade, you will get 25.8 millivolt. Okay, so that is that VT. And so when the voltage is greater than, it is 25 millivolt is a small value. Okay. So how many millivolt makes 1 volt?
1000.
1000. So 25 millivolt is very less when we are talking of, like, 5, 10 volts in the reverse bias. So the exponential term in that equation, if you put this negative voltage, right, then the exponential term becomes negligible and 1 will dominate. So here this is e raised to. Okay, so this is e raised to V upon N into Vt. So that exponential, because this is negative, it will become really small. So this is your diode equation. This term will become small because V is negative now, and this is what is dominating. So your I will be equal to minus Is, and that Is is the saturation current, and the range of that current is in nanopico, right? That is order of this. It's a very low current in the reverse biased, because from the equation of not only from when you take a real device, you fabricate and you plot IV just as the way you do it in the lab, you will see this graph, right? You will see this graph, but by equation also you can prove that yes, for all this very low, this voltage is the current is of the order of IS. Okay, so we are now proving analytically by equation, and when you see the graph also, it obeys this equation, and that is very important. So the current in the reverse direction is constant and is called saturation current, because for whatever V you are changing, the term exponential term is negligible and your I is equal to IS. So it is almost constant, as you can see here, and it can be proved by the equation also. Okay. and it is of the order of 0.001 pico. Pico is 10 raised to minus 12. And remember, when the diode is conducting, the current is in milliampere. When it is in this region, I had said you before also. When it is in, this is in milliampere. Okay, so this is all in milliampere. When it is here, it is in micro. Okay, and then nano and all, and nano pico, and that is almost zero, we say. And this is because of the minority carriers, okay, because of the temperature, not because of the voltage. And then here in the reverse also, you have this in the nano pico range, the current, which is almost, you can say, negligible or zero, but it is still there. You can say that there are few carriers that are always moving. And that is something that is not desirable, because it should be completely zero, right? But that's not possible, because this is material, a chunk of material, and the electrons, they get a medium, it is very continuous, there is no breakage, right? If એક ટુકડો છે and then another is at few distance from there, still the charge can travel. Vacuum hoy to it can travel. So these are all the things that yeah, so that is always there, but that's okay. It's really a low value, and we say it's leakage current. Okay, so with that thing in mind, we'll go one step ahead. Did we do this problem? No, yeah?
No, we don't do it.
Very good. So now if you see, this is from your book only, and if you see that you have this D1, D2 connected this way, 1 volt is given to D1, 3 volt here, and you are required to find out what will be the voltage here, provided there is a resistor and minus 3 volt that is applied as this terminal. And you have to find out this V, and you have to find out this I. So anybody would like to peep in and help? And if you if you reply, I'll request you to leave your ID in the chat box. By the way, your lab is Wednesday, right? What is the time?
2 to 5.
2 to 5. Correct. So this Wednesday you will have your lab, and we will start with LT Spice. Then we will show you next time in the lab also some demo. Yeah, anybody would like to say something? How will you start?
Ma'am, can I help?
Yes. Please try. You are all learning. It is not that it has to be correct. We can discuss. So I'll help you. Very good.
Yes, ma'am. As we can see, ma'am, D1 and D2 both are in forward bias, so both are conducting.
Okay.
And so
Right.
the plus 1 volt. So the plus 1 volt will be the voltage of the at the junction, which we can see over here.
So this plus this, because this is short, right? Conducting.
Yes.
You can say it is
Yes.
short. We are using ideal diode. Remember, this is very important. Okay, so you have to use ideal diode model, and because this is short, you say 1 volt will come here, right?
Yes.
But ma'am, how can we say that it is forward bias? Because we don't know the V.
That's what you have to find out. So we have to find out V across the terminals, okay? So now here this is minus 3 volt. So what it means is across the ground. So here પછી ground હશે. Okay, and આ battery હોય તો this is minus 3.
But in this case, both D1 and D2 will be forward biased.
Ground છે, so you have to find out voltage between this point and this point. That's what it means. Similarly for here also. V છે, right? So that is અહીંયા ground હશે. અહીંયા plus 3 છે એટલે આમ, right? And અહીંયા ground છે. So, right? So between this and the ground point, V એટલે. So now, as he said, he is very right. Okay. What is your good name? Hello? Where are you? I'm audible or no?
Yes, ma'am.
અરે તારું નામ બોલ.
My name is Taram. Taram.
Dharam, very nice name, Dharam. So, see, Dharam is right that both of them will be forward bias because this is positive, and here it is -3. Let me remove this, okay? Okay, and then this is -3, so both will be forward biased. Now, both will be forward biased. So, yeah, 1 volt, he said, okay, then why not +3 volt? So, this is short. So whatever voltage is here will appear here, or whatever is here will appear here. But now this is +3 volt and this is +1 volt. So which voltage will appear is the question. Okay. Okay, 1 to barabar I'm saying, but then what about +3 volt? So what do you think? 1 volt will appear or +3 volt will appear? House. So there is a competition. In a competition, who wins? The one who is more stronger. Okay, I'm giving you a hint. So now both are like conducting, and either of the voltage has to appear here. Now, who is a stronger contestant
3
here?
volt.
+3 volt.
3 volt. So now see what is happening. You know, now if you talk in terms of IV curve, okay, so 1 volt share and 3 volt share. So this is an expanded version, okay. તો આપણે IV curve હોય તો સેમ ડાયોડ સેમ છે, એટલે એનું IV curve સેમ જ હોય, પણ because of પણ ડાયોડ બે અલગ છે, okay, and one you are giving a strong positive voltage, okay, એટલે અને બીજું ડાયોડ એક જ છે, અરે I mean same kind of diode but they are different diodes, okay. એટલે એમાં શું થશે, જેનું સ્ટ્રોંગર વોલ્ટેજ હશે will start conducting, you know, with respect to time little bit earlier. બે ડાયોડ છે, સેમ ડાયોડ છે, you are giving +1 volt and then +3 volt. So +3 વાળો થોડું in you know microsecond, ભલે માઇક્રો કે મિલીસેકન્ડ હોય, સેકન્ડ નો 1000 મો ભાગ હોય, પણ it will start conducting little earlier કારણ કે it is getting more voltage. If you talk in terms of IV curve, this will start conducting, you know, in some microseconds little earlier than this guy.
Yes.
That way it will short this point here. And as you +3 થઈ જશે, okay, so this will be now 3 volt. Pardon?
And the V1 will be blocked.
So now this is 1 volt, this is 3 volt, and then this will be reverse biased. You are right.
Yes.
But the stronger voltage will appear because if you think graphically point of view, value in fraction of second, it will start conducting earlier. And now if you want to find out I and you have 2 voltages, then what will be the I? You have R also. So this voltage minus this voltage divided by 2. So 3 minus -3. So કેટલું આવશે? And 2
milliamperes. 3 milliamperes.
3 milli. Very good. So 3 volt and 3 milli. Is that clear?
Yes, ma'am. But if we are considering ideal diode, then the time to appear will be 0 seconds at both.
You are right. I see. In reality, nothing is ideal, but આપણે ideal લઈએ, બરાબર છે? જેવું it will જેવું 0, then it will when it so once it reaches 0 and this is +1, it will start conducting. એવી રીતે I conducting કરવા મળશે. પણ see, if you talk in terms of time, okay, in fraction of second, this will conduct little earlier. It will millisecond, 10⁻⁶ of second, or microsecond, 10⁻⁶ of second. It will start conducting little earlier.
Yes.
But even if we consider the same time, then also when 1 volt will come on V, D2 will be in forward bias only. So eventually 3 volt will only come there.
Now, see, you are right. See, what I, in reality, how you think. See, this is about when you talk of IV curve, right? I share, IV share, right? So this is about voltage. And if you have a higher voltage, this will start little conducting earlier than this guy. और कंडक्ट करे तो वीक हो. Here the main parameter is voltage. એટલે એ તરત જ શરૂ થઈ જશે. ઓલું કદાચ શરૂ થાય તો વીક હોય. એટલે આ તો શરૂ થઈ ગયું, શોર્ટ થઈ ગયું. The voltage is there, so it will completely reverse biased. This is all happening in, micromilliseconds. Correct? I'm audible?
Yes, ma'am.
Okay. Okay, so similarly, how about this? Now you should be able to say about this then. See, this is plus 3 volt. And R plus 1 share, R plus 3 share. So which one here will conduct?
D1.
Yes, ma'am.
D1. Very good. Right, because the potential, this difference is more. And D1 will start conducting, which will, so this 1 volt will appear here, and this one will get into reverse biased, and so this is 1 volt. So how much will be the current?
2 milliampere.
2 milliampere.
1 milliampere.
This minus this. Okay, 3 minus 1 for you, na? Divided by 2. This was 3 minus minus 3. This is 3 minus plus 1. That is 1 milli. Okay? And this will go into cutoff, this will be conducting. Barabar? This is more reverse biased. Sorry, this is more forward biased. Here, વધારે positive હતું. So this is more forward bias. Okay, that way, simple way. This is more forward bias, here this is more forward biased. Here this is conducting, here this was conducting. So when you see both are conducting, but once this starts conducting little, as I said, this will get, the voltage will appear here, this will be short since it is ideal diode, and this will get into cutoff. And similarly, once this is conducting, 1 volt will appear, which will, so 1 volt is here and plus 3, so this will make that into cutoff. And so these guys are gone, they are driven into cutoff. Initially, although it may seem, but once you on it, it will get into cutoff. Here also it's an ideal diode, and here see, now very precisely you have to look into, and as it says, this is ideal diode, and you have to use, and VF is here. VF is given here, and is 1 kilohertz. The frequency is 1 kilohertz and 10 volt peak sine wave. our input share. Okay, so it is a sine wave and it is 10 volt. So this is 10 and this is minus 10. And this is 1k, frequency is 1k. Okay, and stretch the waveform resulting at V0. So we have to sketch this, okay, and that is appearing at the output V0. So this V0 output, how it will be, input is like this. So how will your output be? And what is the positive and negative peak values? So positive suasa and negative suasa. So if we start with this, so Dharam, you leave your ID in the chat box and you can unmute your microphone, or if there are more, you can raise your hand. I don't know because I can't see. So anyways, you can unmute your microphone and tell me, any one of you. Right? What will be the output V0? So when you have such a wave, what did I say you in before? How you will analyze, you will divide into two halves, positive half and negative half. So when you start with the positive half. So for the positive half, for the ideal diode, this will be conducting or not conducting?
Conducting.
Conducting.
Conducting, absolutely right. And for the negative half, it will be conducting or not conducting?
Not
Conducting.
conducting.
Not conducting.
Conducting. So if your input is like this way, a sine wave, right? Then your output will be what?
Sine wave with only positive cycle.
Excellent. See, then I'm just superimposing. Okay. This is 0 wave. So that will be your output. And your negative is 0, so straight 0 just. Okay, so that is about your output here. Now, how about this? You are having ideal diode model. So, Amar Sutha, sir.
Sine wave with the negative one.
Exactly. And your frequency will be?
1 kilohertz.
Same.
What will be your this?
Same frequency.
Same frequency.
In frequency. Yeah.
Same frequency.
So now let's say here also. Now another question to you is that let's say this is plus minus 10 volt, okay, and this is shorted. So all this, so for the positive half, 0 to plus 10 volt will appear here. Okay, 0 to plus 10 volt will appear here. And then what about this 1K? So you understand this is short. The J volt at this point is same as this point. So that's why your voltage will come here. And for let's say 1 volt, the current will be, right? For 1 volt, the current kitlo hoy? 1 milli, right? Then 2 volt, so it is this voltage divided by this R. So accordingly, your I will flow. R will remain same. Your V is changing, and hence your I through this will also change. Your I will be such that, because this is voltage is here, so 10 volt hoy. So I is equal to V upon R is equal to V by I. I is equal to V upon R. Voltage divided by R is your I flowing. Okay, so your I will change as per the voltage. સીધી વાત છે ને? R will remain same. If I ask you I, that's what I'm telling you. Okay, હું તમને I પૂછું તો તમને ખ્યાલ આવ્યો ને? I will change as per the voltage here.
Yes, yes.
Yeah, 2 volt હોય તો 2 upon 1k. 3 હોય તો 3 upon 1k. So on. Okay, so now, so see, that is the nature. Okay, your I will flow. I is flowing as per the voltage, and that will change, and this R will remain same. Okay, So here also, as you said correctly, and you can understand about the I. એટલે હું તમને ચેન્જ કરીને એક્ઝામમાં આઈ નું પૂછું તો કન્ફ્યુઝ નહીં થઈ જવાનું. વોલ્ટેજ તો વોલ્ટેજ પછી I see when you look for the voltage, the voltage here. Here it is, this is short. So all of this voltage will appear here. Can I hope? Hello? Audible?
Yes, ma'am.
Yes, ma'am.
Okay. Now how about this? This one. See this one like this way. I discard kari diye. Yeah. Okay, as you say. And then this one. So how about this now? So you will divide into positive half and then in the negative half. In the positive half, it will be the thing here. Positive half માં કયો diode conduct થશે કે બંને non conducting?
D1.
D1.
Yes, very good. So D1 is conducting, so you will get whole positive half. And here D2 will be conducting, so you will get whole negative half or no?
Yes, ma'am.
Yes, ma'am.
So whole whatever is here at the input will appear at the output. Correct?
Yes, ma'am.
And
Yes, sir.
similarly, your current will also change. And for a negative cycle, the direction of the current will change. Okay? Current you find out the same way. It's just the direction. If I ask you about the current to plot, the current will follow the voltage. It's just that the magnitude will change. Right? The current no curve the voltage if I ask you to plot. But the magnitude will change. Then similarly here, this is the first like આપણે માનો કે બે ગેટ છે, there are two gates, so this is the first gate. If it can pass through the first gate, it will pass here. Then we have to think of the next stage. So when you have positive half, then it is conducting D1 or not conducting?
Conducting.
Conducting. Very good. So D1 is conducting for the positive half, and this guy is also conducting, so positive half will appear here. And about the negative half, if it passes here, then we have to think of this thing, right? So for the negative half, will it pass through here or no?
No.
No, it won't pass.
So this is open, right? No current is flowing, so no voltage is developed, so V0 0 થઈ જશે for the negative half. And the frequency will remain same. Our frequency change નથી કરતું. Okay? So diode will not change the frequency. So here this whole your sine wave was passing. Your peak value were this way and this. Here your negative peak was 0 volt, as you can understand, 10 volt, and this is your frequency. Okay, now this is a good example, and whosoever will try to help us, you will write your ID in the chat box. Now, here also you can see two resistors and a diode in parallel with this 1K ohm resistor here. And you start with positive half. The positive half must say
It will pass through
It will pass through D1.
It will pass through.
current will pass through a less resistive part. Okay. So when it is an ideal diode model, and when you have a positive half, this is like a wire here. Okay. Current આમાંથી પાસ થઈ શકે, પણ એને બે રસ્તા છે, તો જે easy રહેશે, we take also we do that way. Now the road which is easy to walk, we will take. So that way here also it will take a easy path. So for the positive half, it will take this path. આમાંથી નહીં જાય. કારણ કે આમાં resistance છે. અહીંયા almost zero resistance છે. ખ્યાલ આવ્યો? અથવા તો let's say if the diode in reality has the resistance, but it is in few ohms. Okay, it is in few ohms. સમજાય છે?
Yes,
Yes.
ma'am.
Yes, ma'am.
Yes, ma'am.
Then this positive, for the positive half, whatever it is, as we say, that whole thing will appear at the output. Okay, it will follow. Your output will follow the input, same thing. Ideal diode model. But when the negative half, what will happen?
It will pass through
Voltage
zero.
is divided V by 2.
Voltage divide.
Voltage will be divided.
Very good. So now this is open. This is like not there, but this still allows negative voltage with it. Resistors ne ki fail na pade. Current to pass thaya, right? So now how much will pass? So that you know that now this is not that this segment. So your circuit is this segment and this R resistor. This is only your circuit. And the voltages you use the simple this thing that this R divided by this plus this, whatever comes in the path. Okay. So your V0 is 1K, VI 1K divided by 1 plus 1. એટલે half. એટલે આ voltage divider થશે. And your peak voltage, if your input peak is 10 volt minus 10, your output peak will be
V by
5
2.
volt minus 5 volt.
minus 5 volt. Both sides. Right? So this will be accordingly reduced. Minus 5 volt will be your peak and your frequency is still the same. એટલે સમજવાનું ગભરાઈ નહીં જવાનું ફ્રીક્વન્સી પૂછે તો ફ્રીક્વન્સી નું શું ફ્રીક્વન્સી નું કઈ નહીં થાય એ જ રહેશે. Okay, now here, this is really a good example. Now you should remember ideal diode model and you should try to see the circuits properly, this circuit, and you should first identify where is your diode. બરાબર છે VF ક્યાં છે તો VF is here and these are the two diodes and this is grounded here. Okay, અહીંયા plus 15 voltage છે અને અહીંયા current source છે. You know this is a current source and there is a voltage here and here you have to find out is V0. એટલે આમાં તો V0 જ કયું છે આપણને find કરવાનું. So now you may be confused કે ભાઈ હવે I છે ને I છે તો શું કરશો? The voltage also given and the current source also is given. And here VF, so you will start first with the positive half and then you will go for the negative half as we have been doing, right? But the thing here is before you get into positive half and negative half, you have to understand the circuit. And yeah, plus 15 volt છે ને 1 milli છે તો શું કરવાનું? Anybody any idea?
We can find voltage at the point of intersection of
Pardon?
D1 and D2.
Pardon, once again.
We can find voltage below 1K resistor.
And you are right. We have to find voltage and if needed current also. But now this is given 15 voltage and a 1 milli. What you will use both or either of them or how it goes?
Ma'am, no matter the voltage in the branch of the current source, only 1 milliampere current will pass.
Once again, slowly.
Ma'am, as there is a current source of 1 milliamperes, no matter the voltage across the terminals, 1 milliampere current will pass.
Very good. Very good. This is what I'm looking for. So who is this now? Dharam only.
Yes, sir. Ma'am.
Yeah, write down your ID. Okay, very nice. Dharam is right. See, voltage we give Y to get current. Whatever. So now here you already have a current source here in the circuit. Now you should, as an engineer, you should also remember that like this is battery. Okay, this voltage is a battery. So in your phone or laptop, everywhere you have battery. So this is the potential through the battery you give. Current source kay vechato nahi male. Okay, so that also we make it using transistors only. So to get a current, the goal of this, see, this is what is this doing? It is processing your signal, your information, and what is traveling is the current. Your information is in form of current, which is traveling through the device, and it will appear at the output, peripheral device or the circuit or wherever. Okay, so what is propagating is the current. And that is what is your information from one end to another end. It is transmitting through the circuit and through the medium, and then again through the circuit. And then you are listening to me. So there is a speaker, there is a peripheral, and it will be converted from one energy to another energy. But main thing what I want to point to you is the information is traveling in form of current. So all these voltages we are giving is to generate. So let's say if it's a sensor, right? So sensor will also generate signal depending on the parameter, but to generate that it needs energy, right? Because the signal is the current, but to generate that you need an energy, right? And that is given by the voltage. So the goal of this voltage is to establish a current only. But here now you are given a current source. And what does it mean? This is a constant current source. So whatever the voltage is, voltage this will remain 1 milliamp only. So when there is a current source, this is a boss. Remember one thing, you cannot buy a current source the way we do. Okay, we have to make a current source using transistors like BJT, let's say, or now in circuits MOSFET, and voltage source. Okay, 1 milli છે તો એ રીતે you will have accordingly. When you make this, there is a circuit equivalent to this. Okay, so there are few transistors that are connected through a voltage source, and that the current will pass is 1 milli. So that will be this circuit hole replacing this. But if you just think of the symbol, this is equal to some circuit which has transistors and voltage source, and the current is accordingly 1 milli depending on the voltage source and the parameters of the device, the transistor. But if you make it into a black box, that circuit, it is this symbol, and the current will remain same. Emma fluctuations nahi thai. Okay, the circuit is such. Whatever, then so I mean, now this is equal to this circuit, which is transistor and and voltage source. So this is external to the circuit, and any circuit જોડે કઈ લેવા દેવા નથી. તો અહીંયા જે પણ voltage source હોય, whatever may be there, above, below, will have no impact on the value of this current source. So this is a king, this is the boss. So આને ભૂલી જવાનું પછી. You have to forget. 1500 હોય કે 50 હોય, whatever, right? So you forget this and you take this as your circuit now. So you start from here and you take this as 1 milliamp, which is going to flow through here. Okay, so your now circuit is reduced and this is no more there. And the thing is that now you start with the positive half. So don't never forget this, your principle. So if you are starting with the positive half, right? And as you can see, this will go through this. So the voltage here developed will be how much? This is 1K, this is 1 milli. So 1 volt will be developed here. So અહીંયા 1 volt થયો. Okay, this terminal is 1 volt. Or no?
It will be 14.
It will be 14 volts, ma'am.
14.
Sorry. So this R is 1 volt. The current flowing, let's say if the 1 milli
across R is 1 volt.
this will be 1 volt. Okay. Now, so we have reduced our circuit. Now, if you talk of the positive half, which is appearing here, then D1 will be forward biased or reverse biased?
Forward bias.
Forward.
A negative share.
Reverse bias. Positive.
Positive share. And this is negative and this is positive. So if this current, this is 1 volt here. And what about D2 then? A positive, a negative, a positive terminal, a negative terminal. So D1 and D2, what will happen?
D1 is will reverse bias and D2 forward bias.
Forward.
Very good. Now, why is D1 reverse biased? See, you can understand this
Because
is negative and this is positive here. Okay, a zero share. This will also start. This is zero only. Okay, and this is going positive. So now, so this is forward bias. D2. Is your D2 forward bias? So this is at this potential ground. Okay, a ground થઈ જશે. And this is all positive going. So this guy is what? Reverse biased. Are you getting me?
Ma'am, but for negative
See,
half cycle, D2 will be reverse biased, right?
नहीं હું કહું. See, just think of this much. આનું વિચારો, which is appearing here. This is ground. And 1 milli is passing through this R. This is 1 volt. આ તો થશે ને આમાંથી આટલું પહેલા તો આવ્યું એટલે 1 volt થયું. So once this is 1 volt and this is ground, this will be what? અહીંયા 1 volt હોય અને અહીંયા ground હોય તો આનું શું થાય?
Conduction.
it will be short circuit.
Short circuit. So if this is short, then this is 1 volt, right? So as you short થઈ જશે, so this potential. And now here at the same time, this positive voltage is coming up. Okay. This positive voltage is coming up. And this is negative here. So આ શું થશે?
Open circuited.
Open. So this is open and this is short. This is like this segment is not there. At least segment રહેશે. And this is already shorted. This point is same as this point. Okay. So the voltage here is what? 1 volt.
Yes, it is 1 volt.
So if I am talking, see the voltage is 1 volt for this positive half. 1 minute. Right? This. See, if I am showing you step by step, then sorry. Let me draw a bigger half, positive half, and a negative. So if you have to draw, if you are asked in exam and if you have to draw, right? So it is 1 volt. It is, yeah. Now, so it is 1 volt for all this positive half. Right?
Yes, ma'am.
Yes. So see, અહીંયાથી આ positive half છે અને આ 0 થી start થશે, right? So it will start from 0. It will go to 10 volt, whatever. So the output is 1 volt constant. So આ 10 છે. So this is 1 volt. Okay. So as is જ્યારે 0 અહીંયા છે ત્યારે આ 1 volt and it will go like this way. Okay. And it will be 1 volt for this 0 also. Here 1 voltage hase. Okay. So this is how it is following up to here. હવે negative છે, અહીંયા negative શરૂ થશે. This line, let me remove this little line here just to show you. Okay. અહીંયા 0 સુધી તો આટલું આવ્યું. Right? So that is this. So for the positive half, right, a positive share. So for this, it will from this 0, it will be 1, and from here up to this 0, I know 0, it will be 1. Right? And now we will go for the negative half. So now we start with this negative half. Okay, so now it is 0, then minus 0.1 થી start કરીએ. So 0, then minus 0.1. Let's say minus 0.1, minus 0.2, minus 0.3. That way you start. Okay, so if it is minus 0.1 or 0.2, 0.3, 0.4, 0.5, 0.6, all, how will this be?
Forward bias.
Forward biased.
R1 છે voltage. Okay, and this is minus, so this will be forward biased from there only. So minus 0.1, 0.2 a forward biased થશે. And if this is forward biased, right, then your output will be
VF plus 1.
એટલે આ minus 0.1 હોય. Okay, listen carefully. Minus 0.1 છે 0.1, then plus 0.1 એટલે 0.9 આવ્યું. 0.9 પોઝિટિવ આવ્યું કે નહીં?
Yes.
બધું કરવાનું ને કરંટ પાસ થાય છે તો.
Neutralize.
This voltage is, let's say, minus 0.1. Then similarly 0.2, minus 0.2 to 0.9 સુધી જઈએ. So this voltage is already there, 1 volt across here. Plus આ થશે બધું. So 1, જ્યારે 0.1 હશે તો your output will be minus 1 volt plus minus of minus this. So 1 minus 0.1 એટલે 0.9 થયું, 1 volt હોય તો 0.1 volt હોય. let's say 0.1 volt negative છે, આ 0.2 volt છે, આ 0.3 volt છે, તો 0.1 volt હોય તો positive 0.9 volt થશે. ઓકે, તો અહીંયા આવશે નીચે. આ 1 volt છે તો ત્યાંથી સ્ટ્રેટ લાઈન કરવાની અને આ 0.9 volt પોઝિટિવ થશે. ખ્યાલ આવ્યો? This will be then 0.7 volt that way. This will start then coming down. Are you getting me? So let me show you here. How can I add? So when you talk of peak, જ્યારે 0.9 minus 10 volt હશે, જ્યારે minus 10 volt હશે ત્યારે શું થશે?
minus 10 volt.
Minus 9.
Minus 10 plus 1 એટલે peak if you talk it will be minus 9 એટલે એ follow કરશે. Okay, so peak will be minus 9 if you talk that way. And let's say here, right, so 0 volt it is 1 volt, then 0.1 volt, then minus 0.1 plus 1, so that way it will go. And a minus જ્યારે 1 હશે, let's say this is minus 1, right? So at minus 1 it will be 0. Minus 1 is 0 થશે. So this is minus 1 plus 1, so your output is 0 volt. માનો કે અહીંયા minus 1 છે, આ minus 1 છે, તો અહીંયાથી straight line કરો, right? So that this will be 0, so it is following this way. But if you are asked peak, then your peak is minus 9 volt. So this is little tricky, but if you understand nothing. So you have to trace your positive and negative, you quantify. કે ભાઈ ઓકે હું પેલા 0 થી કરું, you know, even if you are taking positive half, you can start from 0 and just quantify the values and put here, right? તમને આપ્યું છે નંબર તો you start quantifying, you start with 0 and like that way. So but I mean then by practice you will know ki bhai how much you divide your range. So for example, now here when you were with the negative half, right? You can think that way, that you start with 0, then minus 0.1, 0.2. So 1 volt આવે ત્યારે 0 થઈ જાય. Then if you go above that, and then you jump to the maximum peak. And whatever is asked you target, you did not then think so much. But if I ask you that in this case, what will be the voltage at minus 1 volt, then you should be able to visualize and calculate. So that was the goal. આપું તો કદાચ બધા કરી લે, પણ હું -1 આપું તો કન્ફ્યુઝ થઈ જવાય. And if further I ask you why, which is what I do in whatever exam I take, then you will be more confused. કારણ કે કદાચ જોઈને કરી તો લઈએ કે ભાઈ આ જોયું છે તો આવું આવડે, but why is important. ખ્યાલ આવ્યો?
Yes,
So I
ma'am.
spend more time because in the exam you should not be confused. I'll not put the same thing, right? Of course, but I'll put similar things. So now you know that the diode curve is exponential, it is not linear. And as I said, in the real curve, in the piecewise linear model, RD will remain same, but in the real curve, exponential one, your RD is changing, and hence we say it is a dynamic resistance. And it changes as per the voltage because, right, as you can understand now, you can visualize. And that R is equal to V by I, and this is given by change in V, delta V upon change in I. And if you solve that, you will get RD is equal to, if you take delta V upon delta I in your diode IV curve, right, you will get this equation RD is equal to NVT upon ID. And you can see that if RD is less, I mean, so these are inversely proportional. It is 1 upon, right? So more current, less RD, but it is the other way. R changes, so current changes, okay? So it's not that the current is less, and yeah, so depending on the voltage, you will have the current. But if you think of the physics, because of the voltage, R is changing, and hence ID is changing. But one is increasing, the other is increasing, and the other is decreasing, inversely proportional. Is that clear?
Yes, ma'am.
Yeah.
Good. So you can find out for a given current, you can find out this RD. And this current is a function of voltage again, okay? So if now we'll go, nearer to building up the circuits. Remember, this is a simple diagram, okay? And the point here is there will be a resistor. We are making it 0 for now, just to visualize the concept. And remember now that this diode is to process your signal. And to process a signal, right, if you want to do some everyday action or whatever, sleep or run, a person should be alive, right? That way, here in the circuits also, the device also, to operate the device, to process, to make it work, to process a signal, that is your current, right? It has to be on. તો પેલા device ને on કરવું જરૂરી છે, and then you have your signal. So now you have two things to do. You have to on the device, and then you give the signal that you want to process. Okay. So now these are two voltages, okay, that you are giving. The first voltage is to on the device. If the device is dead, it cannot process. Dead means off. It cannot process. So you will on the device, and then you will give the signal that you want to process. Let's say I want to process a signal that is just generated from the sensor. Okay. Now, if the sensor is giving me current as the output, then through some amplifier, there are amplifiers that will convert current into voltage. So we say resistance amplifier. Okay, so it will convert. So current voltages, they are convertible. So we have amplifiers that do that. If you have voltage as an output, no problem, right? So you can add up two similar quantities here. So if you have two voltages, you add up by superposition. You have studied all this. The resultant voltage is addition of the both. So now we want to process a signal, let's say that is just generated out of in your circuits, or you want to make it use as a rectifier or whatever. We'll see many applications, or just a simple thing. I want to pass a signal that is just generated, a voltage signal which is generated from the sensor. So I want to process this signal. So I have to on this diode, and to on the diode, you give 0.7 volt, it is on. So you will need a battery to on, and that is, you will set it. You will not set it to 0.1 or 0.2, then it is still dead. So you will make it to 0.7, the diode is on, and now to that circuit, you will give the voltage of the signal that you want to process. So here you have now this scenario. This voltage VD is to on your device, or to give a condition that it will process your signal, that is making it on here. Okay, and here it is just two terminals, so we don't have that complexity. When we do transistor, it will be three terminal, and three terminal means you will have two voltage sources. If two voltage sources, then two IV curve. So there, how many currents are passing? So current is just one, we are lucky, but in a transistor, current is one, but two voltage source. Here, one current, one. So a two terminals, so one voltage source. Okay. So that voltage we will give across this diode. So now to that, this is your VD, the signal that you want to process. Because this diode is nothing for show. It is not a showpiece. It is for a use. And that use is you want to process your signal the way you want, the way, because there are a lot of devices, depending on what kind of signal processing you want to do, you will use the device, either transistor, diode, or whatever, however you put it. So now this is the signal of your concern. This is the signal that you want to process. And this is to set up the diode in an on mode, and we say this is the bias voltage. Okay, we say this is biasing, making diode alive, making diode work. And to that you will add the signal that you want to process, and this is what is given to the diode. I hope you understand. Now see, why we have to make it on? It can be made on by this signal also. That can be your question, that madam aaj signal on kari de, to શું જરૂર છે? Right? But you must remember that the signal that if we are processing, right? So these are, if you are processing a signal, let's say from a sensor, that is really a small signal in millivolt. So if you don't have this voltage here, this bias voltage, and you will just give millivolt to that, it will always remain dead. So this millivolt falls here somewhere. Here, the diode is always dead. So if this voltage is slow, but if this voltage is big enough, then okay, you don't need this. If I'm talking of 200 volts, let's say, okay, then 0.7 એ કઈ નથી, અને right, it is always on. 200 volt માંથી 0.7, if you do little voltage drop, even if you consider, it is still 199 point something. So it is not necessary to have this bias voltage. But when you are processing a signal, in signal processing, the signals are weak. They are of the order of millivolt. If you give that signal directly to the diode and you think it will rectify, no, because it's already, so you give enough energy to the diode first if the signal is weak, and that is biasing. Samjhanu? So here, this VD is this VD here. Okay, by 0.7 is the on thing. So this line is VD here, 0.7. To that, I want to process a very, if I want to process a very weak signal, to શું process ના કરી શકું? I can by giving this bias voltage VD. Okay, so it's like you in a multi-storied building, 100-story building, you want to clean a window, a glass window, which is at 99 story. So what you will do? First, you will climb there using a crank or whatever, right? You will reach there and then you will start cleaning. So this is like that. So you first make it operate first with proper biasing. Once it is operate, you process your signal. So if this is your small signal VD, which is superimposed on this VD, which is a DC constant, you will have the resultant signal varying like this, right? On that, this VD, this point, it will vary whatever your signal. If it is sine wave, it will vary accordingly, plus minus from that point. If this is 0.7 and this is plus minus 20 millivolt, right? Then from 0.7, it will vary plus minus 20 millivolt as shown here. And my current, so if I relate that to the current, then my current, where this is current, so my current is going to vary accordingly in proportion to that voltage. But very important thing now, you must understand that this is now let's say this is your circuit. After that, there are other 10 stages of circuit. આની પછીની આનું આઉટપુટ આ સર્કિટમાં જાય છે. Then it goes, let me draw a box. This is a black box of a circuit. It is going to the another circuit and another circuit. So what is traveling is the current. Current આમ જશે, ઈ પ્રોસેસ થશે, પાછું કરંટ જશે, અને આ બધાને VDD છે. Every circuit has a VDD so that it can operate with proper conditions. Okay, so it's like a road which is fully lighted, means energy, and you are moving you are running. Okay, so you are moving is a current, let's say, and the road is ready. So all these circuits are ready with proper biasing and your current is passing, it is being processed, something like that you can think of. So now when you are processing so now this current is proportional. Here your signal that you had to process was in terms of voltage, right? This was voltage, and we want to process this. But what is floating here is current, and we have converted this voltage to proportional current, which is a measure of this voltage only, which you're given as an input. But you cannot process a voltage. What we can propagate is a signal. So now this is current. So this is your current, but this current has to be, if this is sine wave, your current has to be sine wave. And if it is a triangular wave, it has to be, it should follow this. Okay, it should mimic this. So the relationship between this I and V should be linear. Now, if I take this large, if this is large, not this much, if this is large enough, okay, this is large enough, and then this will flow here in this region, this will flow here, and your output will be no longer linear, because now this is exponential, this is a huge, and this is not linear in itself. Okay, so now another thing that you can deduct from here is that if this is large enough, then your output will not follow the input, because this itself, this line is not linear. So you can take a segment of this, that is this little region. You can take a segment which will be linear. I can take a segment and it will be linear for little change in the voltage. If I take here, it will be linear for some little change in the voltage. But I cannot take a huge range of voltage and expect that this will be linear relation between I and V, because the curve itself is non-linear. This is the nature of the device, that for this voltage, every time I on the device, I will get this current only, and for this voltage, 100 times if you on and off at particular voltage, you will get particular current only. So if this range is large enough, your current is not going to follow the voltage and it will be non-linear, and then it means that whatever you are processing is not corresponding to your voltage. So what you must understand is that the current that you want, the voltage that you want to process here must be few millivolt, and it should be less than VT, of the order of VT, 25 millivolt. Okay, so just a few tens of millivolt is fine. If you take a broader range, your current will not, and this current which is flowing through this stage will again develop. If you want output as a voltage, it will again develop a voltage. So our voltage and our voltage, it should be linearly satisfactory, right? They should be linear. So if this is only changing, it will not give a linear relationship. समझाई छे?
Yes, ma'am.
Okay, so that's what is the meaning of this. And we will see this. So you should understand કે આ કેમ છે, આ VD શું છે, કેમ છે. What is this? This is the signal of our concern. But let's say we as a human being, if you want to study good engineering, then you will think, oh, IIT is good or DIICT is good, right? So you need good campus, you need a good surrounding, you need good professors, you need good colleagues, you need all good setting to progress, to make. So similarly, signal also needs everything set up rightly so that it can be processed. Okay, same universal fundamental rules everywhere. So determining diode current graphically. So again, this is all game of, I said electronics is I and V. Okay, and what is flowing or floating is I. So your information is I, and at the output it can be in form of I or V, right? When I am speaking, it goes to the microphone. At your end, it is voltage that is converted into the acoustic signal again in the loudspeaker. So flow current thayuં હતું circuit માંથી, but at the final stage voltage was developed corresponding to whatever I am speaking, only you are listening. So whatever the processing is happening, it is linear. એમાં જો distortion આવી ગયું, you will listen something else. You will not listen what I am speaking, or it will go up and down or with some noise, as you can understand with this kind of example. So that linearity in your signal, and that depends on the nature of the device. And now understanding the nature, we have to confine our signal. If આપણે ખબર છે આનો સ્વભાવ આવો છે તો હું આમ કામ લઈશ. So that's way we make the circuit. So here also, let's say that any diode, it is always, there is a R which protects, right, the current through that. Otherwise it may get destroyed. So you have this, so let's say this is a simple circuit where you have to determine ID, okay, diode current. Now you have a diode R and VDD. And this is a one loop only, એક જ loop છે. So through a loop only one current. અહીંયા ID છે, અહીંયા ID છે, અહીંયા ID, everywhere same current is flowing through a same loop. Now you must understand that if there are two components, one is R, one is VD. What is the time? Okay, I'll finish with this.
Hello, ma'am.
Bol.
Ma'am, I was having one question that in most of devices we see that the voltage of that batteries are 3.7 volt. So why it is so like?
નહીં સમજાણું નહીં. You
Like
can elaborate it.
આપણે ગમે એ device
Where do you see? Hello.
Yes, ma'am. So I was asking that in most of devices we see in today's like the batteries that are including that are having a 3.7 voltage, like we see power bank or other things like that. So why it is so like only 3.7, not
Okay,
like
I get your question. It can be 3.7 or 5 volt or 3 volt, whatever, right? So why some number? That's what you mean.
Yes, ma'am.
Depending on the application. See, that is what is biasing. I'm coming slowly to that. Okay. A simple circuit, and this is a simple concept. But once I start with the BJT, I cannot explain you in a line or a two. Okay. So, but the concept is this. કે ભાઈ આને એક આપણે proper condition આપી. મારે આ small signal છે, which is from some few millivolt, right? And if I want to process this, I have to make it on, because if I don't have this VD, this DC voltage, right? If I don't have this DC voltage, then this signal, this diode will remain off only. Up to 0.7 it remains off, up to 0.5, 0.6 તો off જ છે. So if my signal is small and I want to process, it will remain dead. It cannot process. I have to make it on, and that is here. It is a simple definition of biasing. But to your question, when you are talking of the circuits which are there in your IC, they are MOSFET. They are also transistor like BJT. So in BJT also I'll teach you biasing. A BJT is a 3-terminal device, and in that biasing concept is more stronger. So I will teach you how to bias, what are the techniques, and that will be an exact question. But a simple definition of this is that this is biasing here. And more elaborately, I am explaining you here also. Okay, that now what is biasing? That this is VDD, you are giving some voltage R, and so same current is passing. Give me 2 minutes more, okay? Because I am in between something. Same current is passing. બરાબર. હવે જો R નો IV, if I'm drawing IV of R, it is some line depending on the value of R. R ની value same રહેશે, બરાબર છે? So this is V, this is I. Do you get my point or no? આ સમજાય છે પહેલા?
Yes,
If
ma'am.
I'm plotting an IV curve of R, it is something like this. You agree or no?
Yes, ma'am.
Yes. Now if I plot for a diode, it is something like this. Do you agree or no?
Yes, ma'am. Because of dynamic resistance here.
હા. હવે કોઈ પણ વોલ્ટેજ હશે તો R નું કરંટ તો આમાં જ હશે, આ જ કરંટ હશે કરસ્પોન્ડિંગ. આ તો સેમ જ રહેશે. એમ આનું રીતે આ વોલ્ટેજ હશે તો if some V1 is a voltage, then and for the diode I will get this current. And if V1 is the voltage for R, I will get this current. તો current ની value અલગ આવી for some voltage V1.
Yes, ma'am.
But that alag value cannot flow this with this. They both are in series. You understand now my point, that same current should flow. The same current should satisfy both the equations.
Yes, ma'am. Yeah.
કારણ કે નહીં તો unstable થઈ જાય. It is not possible. That's not the nature works. એટલે એને bias કઈ રીતે કરશું? So see, you have two equations now. ID, this is for diode, it is conducting. Conducting માં પેલો -1 negligible કરી દીધો. It is negligible -1. So this is simple conduction equation in forward bias for diode. So ISE raised to VD upon NVT. And the other equation you can write is the voltage across this minus this. So this is higher voltage minus this upon R is your ID. So ID should satisfy both of them. And if I'm showing you here, right? So if I make a load, so this is your diode thing. Okay, and this is known as the load line. Okay, so next time I'll explain you in detail. And this is the operating point, the biasing point. આપણે bias કરવું પડે. We have to give a voltage where you can operate at a single common current. Okay, and that is, so next time I'll take in detail. Okay, this slope and this line.
Yes, ma'am. Thanks a lot, ma'am.
Okay, anybody, any queries?